Satellites, the magic and distant objects created by human race. They are visible in the night sky as distant white dots, moving along the orbit known to just a few people in the world. Their all-seeing eye makes scrupulous records of our planet environment, from air pollution to rains and floods. But how accurate are these measurements, conducted more than 400 kilometers above the Earth's surface? How can they be validated? The answer might be found in small urban college in the Bronx.
It would be a good time to be Spider-Man.
You just climb up.
Exactly. Just web up.
Yeah.
How far am I going up?
We're going all the way up to the sky,
Oh, wait.
all the way to the sky.
There's no elevator.
Welcome to the roof of our great Performing Arts Center, and what you see here is a gauge. So this is two gauges. So this is one and this is the second one. What do you think? Why do you need two gauges?
In case of malfunction.
You can film them how they talk. You know?
Like a better average of what's going on.
Okay, average is one. What else?
If one malfunctions for some reason.
Very good.
backup.
If one doesn't function, the second one will function. And so if you see two data sets from one and second and they have discrepancy, then you know something is wrong, right?
Yeah.
So you can come here and you can clean it. So this is what is called bucket, tipping bucket device. So it has this little screw. So this is a cylinder with a mesh.
Does the rain get caught in there?
Right, so the rain comes down and the rain gets funneled into this little cylinder here, like a hole. So when water comes down, bucket tips.
Oh.
Then when it fills up, tips. Rain comes down, accumulates water, tips. And then the device, like right now in the main server, we have actually recordings going on. But we know it's nothing because there is no rain.
No rain.
So, but this is what is called tipping bucket. So device register only the tips.
Okay.
So it doesn't register amount of rainfall. It registers how many times the bucket tipping. When, for example, we had an event last week with a huge rainfall,
Oh yeah.
I looked on internet and this thing was going
was
485 tips. You know,
Yeah.
like
Per
tipping
second?
back and forth, very fast, like boom, 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 boom,
Damn.
boom, boom. And so that's basically what device it is. The way they set it up is that every night at noon, midnight, they nullify the number of tips.
Oh.
So you see, it's relatively simple device.
Yeah.
This is an example of the gauge collected dataset. It consists of data collected over 5 minutes interval. Buckets are coded as A and B, and numbers next to them represent number of tips recorded by this timestamp. Each bucket's capacity is equivalent to 0.01 inches of rainfall. Therefore, 22 tips of buckets A and B amount to 0.22 inches of the rainfall, a total since the midnight. This is our main unit here, which actually has a modem. So this one is okay. So here is a modem,
and it has a SIM card. So somewhere here, you see like it's blinking.
Yeah.
So these two wires go to that modem, and then through the SIM card, every time you got a tip, let me just stay.
It stores the data.
Yeah, every time it get a tip, and every time it collects data, it goes through the Verizon cellular connection. So it's basically the same SIM card as in your phone. Look at it like a little phone with a SIM card,
Yeah.
and then the SIM card collects data and through cellular connection send it to the server at NASA in the Greenbelt. So they have a server, they have a main server, and that's how it works. Okay, so the question which you had, Janine, is why we are doing this. So imagine that now somewhere in the sky, you don't see it, only maybe in the night when it's dark, and you see a little dot going around horizon.
Yeah.
That's a satellite. It's called a GPM. GPM. It's called Global Precipitation Measurement. GPM.
We can see satellites in the sky.
You can see satellites in the sky. So the satellites are flying around and collecting data about moisture. So they collect data at different intensities. So it's a device which basically collects electrical signal. And then electrical signal get converted into rainfall. So this device here with the data serves the purpose of validation. If you collect data right now from the satellite, then how accurate it is.
To better understand validation, we can look at the gauge location and see how satellites see rainfall at the same place. Here is a high-resolution image of the New York City metropolitan area. The blue dot is a roof at Lehman College, where a gauge is located. Now we can turn on satellite image with precipitation data. As you see, the colors are organized as rectangles. Each rectangle or pixel is a record from the satellite eye, where the color refers to the specific rainfall amount. Integrating both data from the gauge and satellite's image, we can compare numbers and estimate the accuracy of satellite measurements.
So do you see something attractive if you would be, like, do you see yourself getting involved into a project like this? And
I can't be held responsible for the logistics, like, but I'll supervise.
yeah, you would be supervisor.
Yeah.
Great. Yeah, we need supervisors.
I'm the one.
And anybody want to be a scientist and do statistics in this? And yeah, yeah, good.
Is it like a new technology? Or?
It's not exactly new technology, but for Lehman College, it's a big thing because it gives us opportunity for faculty connect with NASA,
Right.
but also for students, you know, to create small research project and then maybe go to conference and you know, present stuff.
NASA, if you're listening, just take me to the moon.
Take me to the moon.
Take me to the moon.
Thank you.
Awesome.
The journey of precipitation measuring satellites continues. And so continues the bucket tipping on the roof of the Performing Arts Center at Lehman College. Maybe for some of our students, this will be the first step in their journey to the sky.